Now let us take a look at another example. Suppose your function is xy squared divided by x squared plus y to the fourth, and you want to know if the limit exists at the origin or not. Please pause the video, think about this question, then we go over the solution together. Very well. For this question, let us use a general path like y equals to mx. Wherever you see y, you just write down mx. So your f of x and y is now f of x and mx, which is equal to x, mx squared, divided by x squared plus mx to the fourth. Let us simplify this expression. You get m squared x divided by 1 plus m to the fourth x squared. Guys, this expression is different from the previous expression in the example that we did before. In previous example, you only had m involved in the expression. In this example, you see m and x. So as x goes to 0, the limit of the function also goes to 0. So using the general path y equals to mx give us limit goes to 0. Is that enough? Of course not. We need to check more paths. Very well. Suppose you use a different path like y equals to square root of x or x equals to y squared. Let's check this path. This path passes through the origin, and our goal is to find the limit of the function. So wherever you see x, you write y squared. Here now you get y squared times y squared divided by y to the fourth plus y to the fourth, which is y to the fourth divided by 2y to the fourth. The outcome is a half. So what's the meaning of that? It means that as you walk along path x equals to y squared, the limit of the function is now a half. As you can see, 0 and a half are different from each other. What's the meaning of that? It means that the limit doesn't exist around the origin. Now let us check the continuity of a function. This function is a rational function. You get x squared minus y squared divided by x squared plus y squared. You want to know if this function is continuous, for example, at origin or not. Very well, we need to find the limit of the function, and we need to find the value of the function at the given point. This point, where is that point? You don't know. You need to figure out where the function is continuous. You can work with the origin, as I mentioned before, or any other point. But what are those points? Please take a minute or two, think about this question, then we go over it together. Think about this function. Very well, this is a rational function. It means that you have something on the denominator. When you have a rational function, it doesn't matter if it's in 1 variable, 2 variables, or 3 variables or more. The denominator cannot be 0. It means that you have to exclude the solution or solutions of the denominator from the domain. So the domain of the function is all points except for the origin, and you already know that this function doesn't have a limit at the origin. So the function is continuous everywhere except for the origin. Now, what if we define a function the way that we actually add the origin to this function? Take a look at this piecewise defined function. It says if x and y is not the origin, then you have x squared minus y squared divided by x squared plus y squared. And if x and y is exactly the origin, I want to define the function to be 0. Is this function continuous? Please pause the video, think about this question, then we go over the solution together. Remember the definition of continuity of a function. The limit of the function at 0 and 0 is not defined. Even if you define the function at the origin to be 0 or any other number, this function has discontinuity. Let us go over another example. Here you have your function f of x and y is equal to x, y squared divided by x squared plus y squared. And since 0 and 0 is on the denominator and makes the denominator 0, we have to exclude that from the domain. As you can see here, you have a hole in the graph of the function. So what's the limit of this function when x and y is getting closer and closer to the origin? Please pause the video, think about this question, then we go over the solution together. The first method to find the limit of this function is using squeeze theorem or sandwich theorem. First of all, the absolute value of y squared divided by x squared plus y squared is always a quantity, a number between 0 and 1. Why is that? Your numerator is always positive, your denominator is always greater than or equals to the numerator, and absolute value is between 0 and 1. What do? We multiply both sides by square root of by absolute value of x. So we get absolute value of x times 0, which is 0, absolute value of x times y squared, which is x, and absolute value of x times 1 is absolute value of x. Now, you can take the limit of both hand sides. Limit of 0 is going to be 0, limit of absolute value of x, while x goes to 0 is going to be 0. It means that by using sandwich theorem, the limit of the function in between is also 0. Second method. Let us use polar coordinates. You know that you can write x as r cosine theta and y as r sine theta. This is just an equation of a circle center at the origin with radius r. Now substitute these values into the function. What do we get? We get absolute value of r cosine theta, r sine theta squared divided by r squared. The outcome is equal to r times absolute value of cosine theta, sine squared of theta. Remember that cosine is always sandwiched between 0 and 1. Sine is always, and the absolute value is always sandwiched between 0 and 1. So the multiplication of two numbers which are less than or equals to 1 is less than or equals to 1. By multiplying by r, it is always less than equals to r. As r getting closer and closer to 0, your right-hand side is getting closer to 0. Left-hand side is 0, right-hand side is 0. It means that the limit of the middle value, middle expression, middle function is also 0.